In this video, I'm going to show you how you can use the Napari assistant to design some pipelines, save them, and then process this batch. So before we train a pixel classifier, so we're going to use it in our pipeline. Just one thing to start with. On my computer, I can show you, I guess here, I have two GPUs. By default, the GPU 0, which is the Intel GPU, is used by the Napari assistant, which is definitely not convenient because it's a very small GPU. I have a larger GPU here, and so I can change that. It just requires a bit of using the terminal. So if I open this here, I have it in memory. So if I, if I import, so PyEC Esperanto prototype here, which is there because I installed a Napari assistant, then I can tell Napari assistant which device to use. So in my case, it's 0. So let me show you when I do that, it tells me that it's really my big GPU, the RTX 3080, that is going to be used. So if you see that when you're running, it takes a lot of time, and when you look at your resources, it's using your small GPU. If you have 2, you can change it that way. All right, so I'm going to open the Napari assistant. To do that, you can go to plugins, and then you can go to assistant here, and it opens a bunch of things like this. So first of all, we're going to use the pixel classifier. So we're gonna segment the image. So I guess here, I'm not always very, I don't remember how to do this all the time. So you can, when you hover this, you then have all the different options. So for example, in this one, which is called, so let me remove noise, then you can see that you can do a Gaussian blur, a min box, a min sphere, a median box, or a median sphere, okay? So here, in our case, it's not going to be binarized. It might be in label. And yes, here you see you have semantic segmentation apply pre-trained APOC. APOC is for accelerated pixel and object classification. And that's what we use to do semantic segmentation. So I'm going to hit this button. And so one caveat with this, with Napari assistant is that it's going to always apply the first algorithm. So if the first algorithm is a bit needy in resources, you're going to have to wait, but most of the time it's fine. So here I'm going to choose which image I want to process. So here it's myelinated neurites, so it's the right one. Then here I'm going to change the operation. I want to do semantic segmentation with a pre-trained model. And then I need to here put the name of my model. So what I'm going to do, all right, so let's reduce everything. This is the pixel classifier I trained. So if I do a shift and right click, I can, so not this way, I can copy as path, and then if I go back to Napari, I'm going to paste it. And I just need to remove the quotes. So I have quotes here, and I have quotes at the beginning. And you see, it gives me the results. All right, that's great. So I don't need the background. So thing I'm going to do next is, and actually I'm going to just do this. And so one nice thing when you do a pipeline like this is that you can use this button that shows you all the different images. So these ones, actually, as I won't do anything with these guys, I'm just going to remove them. So it could be useful, but here it's not. And so I have first image, and then after pixel classification. Now I don't use the background. I just want the neurites. So here I can actually do an operation on it. So how do I do this already? I can I don't remember if it's not in there because I want to extract the pixels that have a given label. So it's going to be in process labels. And here should be there, I guess. Exclude binary edge and no. Yes, it's in here. Here I can do, so even if it's not on labels, I can do not equal constant or I can do equal constant. And so here I want to get the pixels that have an intensity of 1. So here it's not marinated newts anymore, it's result of semantic segmentation. And operation is not a threshold, but I told you I want to get the ones that are equal to equal constant. And the constant is 1. And you see now I get what I want. So if I think that I can remove those small structures that correspond to noise, maybe what I can do is to extract the connected components. So I'm going to have every single object is going to be defined as the pixels that are connected together with a label of 1. I can directly see that I won't be able to separate newts because they are touching each other, but it will already be better. So if I go to label here, I have a connected component, so I'm going to click on this. So that's the correct input, and then I'm going to do a connected components. All right. And now you can see that, these objects are all connected, especially its connected components in 3D. So except when structures are really different, we have one big structure in purple here, one other big structure in darker purple. But maybe if I get rid of very small objects, I'm going to be able to remove this noise. So I need to filter out. So if I do a process labeling, maybe I can exclude, I can exclude small labels. That's exactly what I want to do. So let me, refresh this. So here I'm going to select exclude labels on edges. So I could exclude label on edges. I really want here exclude label out of size range. So if I want to exclude small and large labels, that's what I want to do. Outside size range here, I want to exclude small labels. And so let's see. Can do it this way, or I can directly do it this way. And so clearly I have less objects, so I can increase again. Problem, so it's here, it's definitely because it's in 3D. If I increase too much, I'm gonna miss some of the structures, but maybe it's not a big deal. And if I want to be stringent and only identify structures that make sense, that's one way to do it. And I can keep going and going, and I could also do some distance analysis between the segmentation I get in the newts compared to segmentation I would do with the nuclei. So for example, we could have used stardist to segment nuclei. We get the labels, and then from the labels we could apply it and do some, analysis between the newts and the nuclei and so on. So the nice thing is that then you can save this workflow. All right, sorry. Export workflow to file. So I'm going to put it on my desktop, for example, and I'm going to say my newt, let's say directly. neuret pipeline. Okay. And let's close Napari. So I won't lie, the Napari Assistant is not probably the most stable plugin. When you do it right, you can definitely still do quite interesting things. So I think it's a nice tool. But sometimes, if I go back in time, you see you have some errors sometimes, which is fine. But it's possible when you do so, when you work on the pipeline, maybe at one point it's just gonna shut down and it's fine. The Napari, it's not the most, again, stable plugin, but as you can see, you can still do very interesting things. So if I go back to Napari, so I showed you I need to change. So to tell Napari which GPU to use, the nice thing is that these files, they are set up in the memory. So I just use the up arrow and I can get them back. I'm gonna open the image again. So let me go to my data. If I open the image again, get the different channels. I'm gonna remove the channels I'm not using. I'm just gonna show you that you can then load again the pipeline and process the data, which is a nice feature when you want to process quite some data. And here you don't need to know how to program. So that's a nice feature when you are, like many biologists, not very fluent with coding. So this was called myelinated neurons. So it makes it clearer. And if I go back to plugins and Napari Assistant here, so I can load workflow. So I'm going to go back to my desktop. The pipeline I just saved, open it. And so it should do all the different steps. So process the pipeline and should have what I got before. So it might take some time, but hopefully that should work right way. So you can, you see, it's done. And so if I just look at the last step and my initial image, so that looks like what I had when I was working on my pipeline. And so you could keep on to do the entire analysis for a given task and then apply it to different images.